Hi there, my name's Andy Young. I'm one of the automotive lecturers down at Unitec in Auckland, New Zealand, and this is one of my videos for testing EFI sensors. And on this particular video we're going to be testing a map sensor. Now a map sensor essentially gives a varying signal to the ECU based on the vacuum or lack of it within the intake manifold. And that helps the ECU to decide how much mixture to put in, that kind of stuff. This is a Toyota one, pretty common actually, off the 3 SFE engine, RAV4, 1995, that sort of machine. This is part number 89420-42010. These are really common in sort of the 90s Toyotas, used all over the place. And they have an input, which is vacuum. That's a vacuum pipe from the intake manifold. And there's 3 electrical terminals just there. Now, from memory, let's get this right. This one here, there's my pointy stick, that'll do. This one here on this side is 5 volts in. The middle wire is the signal wire that goes back to the ECU, and that's the one that varies its voltage depending on how much vacuum there is in the intake manifold. And then finally on this side here, this terminal relates to ground or earth, battery negative. Okay, so just to put that in perspective, that's where we are with the sensor. And you can see on top of the sensor there's 2 lugs. So you've got 5 volts in, signal wire and earth. Okay, right. We're going to bench test this. We're not doing an on-car test, that's a different video. This is the off-car testing of a map sensor. And you're going to need a multimeter that's got volts setting, because the readings are taking you in volts. We're going to be seeing the actual volts that the ECU gets. And you're also going to need a 5 volt supply. Now I've got, very fortunately, a power supply that I can vary the voltage on. This is really, really useful, and you're going to need something like that because you've got to supply this sensor only 5 volts. It doesn't, if you give it 12 volts, you'll fry it. And looking on the internet, these are going for around about $280. So don't fry it. Hopefully I won't fry it, otherwise the wife's going to be really upset. Okay, and you're also going to need a vacuum pump. Now on that vacuum pump it's got a gauge, and we're going to be taking readings off that gauge and off the multimeter. We need to know what voltage is, what voltage is represented, what vacuum is represented by what voltage, so we can see if the unit's in spec. And the specifications for this particular unit will be in the workshop manual. So first of all, we need to connect the vacuum pump to this little vacuum input underneath there, look. Now when you put that on, you want to make sure it's a really good fit. We don't want to be leaking vacuum, otherwise again our results are going to be incorrect. Okay, so just to run through the wiring up of the map sensor, we've got the 5 volt feed in on this terminal here. The middle terminal is our signal wire out, and the terminal nearest me is the earth. Now the 5 volt supply is obviously coming from our 5 volt our multiple power supply, and of course as is the earth. Now to wire in the multimeter, it's important that we wire it in correctly, and what we're looking for is the voltage that the ECU sees, and the ECU compares the signal voltage, that's the 5 volt supply, with what comes back via the signal wire. So with your multimeter you want to connect the signal wire to the negative wire of your multimeter, and the positive wire of the multimeter you connect to the positive feed to the map sensor. And by doing that, what you're going to get on the display is the correct reading that will match any manufacturer's specifications charts. Otherwise it'll be the wrong way around and you'll have to deduct the 5 volts to get what you want. Okay, right, so we'll turn on the power and we're going to crank that up to 5 volts. Now we need to first of all check that we are at 5 volts. I'm just going to steal the earth and I'm going to put it on the earth of the feed, so we're going to crank that up accurately to 5 volts. We need to have that bang on, otherwise all of our readings will be out of spec. They'll be inaccurate, should I say. Oh, this is so hard. Okay, that'll do. We're close enough. Okay, so negative back onto the signal wire, and we're now at 0 millimeters of mercury. So what I'm going to do is I'm going to pump this right up to 600. That's the highest we can get, and then it's a lot easier to then just reduce the vacuum using the bleeder valve to each increment that we're going to take a reading of. And we'll take readings for 600, 500, 400, 300, 200, 100, and of course at 0 where we are now. So make sure that that valve's closed, crank it up. Nearly. There we go. Okay, so we're at 600 and we've got 3.94 volts. Okay, now we just bring it down to 500 by releasing some of the... Oh, he's overshot. There we go, so we'll go back up again. There we go. 3.49. Okay, so down to 400 now. There we go. Oh, 3.04. And to 300. There we go. 2.6. Down to 100. Down to 200 now. Oh, he's overshot again. Look. .18, and finally, penultimately, 100. There we go, 100, 1.77, and 0. Just release it all out. 1.37. Great stuff. That was nice and easy. Okay, so first thing I found out is my vacuum pump is not great. I think it needs a bit of a rebuild, maybe a bit of grease putting on that on the rubber piston inside. It is old, it's 20 years old, so you've got to give it a chance. And the voltages that I got are just here. Look, the first thing we can tell from that before we even look at any specifications is it's doing what we're expecting it should do. It's giving us a range of voltages, so as the vacuum increases, the output voltage decreases. That's a good thing. And if you don't have access to any specifications, then it's sort of, within the ballpark. It seems to be working okay. Now, when you're doing diagnostics, seeming to be okay isn't really what we're paid to do. We're paid to sort of know. We need things to be conclusive. And the only way we can be conclusive is to have some specifications to relate those readings to. So you've got to get the workshop manual. Once you've got the workshop manual, you can look at the specs for that particular car by that particular manufacturer, and you can say, actually, this map sensor, it's doing what we want it to do. So there you go. I will do my very best to find the specs for this particular unit. For this map sensor. They're really common, so it should be pretty easy to get it off the net. I may have to pay to buy a manual, who knows, we'll wait and see. But that's how you test a map sensor off car. There will be another video on testing a map sensor on car. And when it's on car, we just leave it plugged in on the electrics and we just back probe on the signal wire, and we use our trusty hand vacuum pump to artificially create a vacuum change, so that again we're going to see a change in voltage, hopefully. Bench testing I think is always better than on the car because it isolates the unit. We're not reliant on the wiring of the vehicle as well. We can just test that particular component on its own. So there you go. Measuring this kind of stuff's really quite good fun, and my students really enjoy doing it, especially the off-car stuff where they can be sat at a desk and playing around with power supplies and multimeters and oscilloscopes and lots of wires and bits and pieces. It's great fun, and it's very interesting to find out where you sometimes get a really clean, tidy looking unit, whether it's a temperature sensor or a coolant temperature sensor or an air temperature sensor or a TPS, whatever it is, and when you actually bench test it accurately, you find that there's a problem with it, and you change it, put a new one on, and the fault on the car disappears like magic. It's really cool. Have we found a fault with it? Well, everything looks good, but we've not compared all our bit of cardboard readings to actual manufacturer specs, and only until we do that can we make a final decision as to whether this component is serviceable within spec or not. Okay, hope you enjoyed the video. If you did, then please do subscribe to the channel, then you'll get notifications as and when new videos get uploaded, and these videos cover all sorts of stuff to do with cars and motorbikes and things, how to test them. Hopefully you'll find it all helpful. If you have any questions or comments, then leave them down the bottom and I'll get back to you as soon as I possibly can. And well, my name is Andy Young. I'm one of the automotive lecturers down at Unitech in Auckland, New Zealand. And really, well, thanks for watching. Cheers, over and out.